So, hey there, guys, welcome back to my channel. Don't forget to like, comment, and subscribe to my YouTube channel. And as I had already told you, that we are going to do mathematics class 11 playlist, and in that we are on sets. We have completed the sets and we have completed the relations, and now we are moving forward with what functions. So, let's not waste our time. And in today's, we are going to talk about what are the functions, what are their types, and what are their domain and range, and what is their operations. Okay, so operations means nothing but performing mathematical operations like addition, subtraction, multiplication, and division to what functions. So let's not waste our time and get started. So before starting, I want to let you know what are the functions. So we are going to learn functions by 3 to 4 definitions. Okay, first, by a set of correspondence, by a set of correspondence, or by set of special kind of relation, by set of special kind of relation. If you don't know what does the word relation mean, previous video, in that video I had explained what is the term relation mean. Okay, so relation is nothing but a subset of Cartesian product of two set. If you don't know what is the Cartesian product of two set, Cartesian product of two set is nothing but a set of all ordered pairs A dot B, such that what A belongs to the set A and A belongs to the set B. And set of all ordered pairs, you know what, the pair which are written in a fixed order. Okay, they are called what, ordered pairs. So I think I made my point here clear. What is the relation? So we are going to talk with the function in terms of relation to, and then we are moving forward with what, one of the most simplest definition in my terms. Okay, in my terms. So let's get started with the simplest one. What is the function? So you can clearly see we are going to talk about what functions. Okay, definition of the functions in my terms, for your understanding, you can say, in my terms. So you can clearly see that I have taken some oranges, and what I'm gonna do, nothing but I'm gonna process them using a what, fruit juicer mixer. Okay, so if I'm gonna process what, oranges, to a what, you can say a machine. Okay, to a machine, and if I am putting oranges as an input, then I am definitely getting what, a glass of juice, that is orange juice, as an output. Okay, so it is possible that I am gonna get a banana shake as output. Is it possible that I am gonna get a banana shake? No, it is not possible, as what, I have provided input as in what, orange juice. So it's like that. What if you're gonna provide a specific input, then you're gonna get a what, a specific output for that. Okay, so one thing is clear. What if you're gonna provide an input, if you're going to provide an input in the machine, you are going to get a what, a specific output. And let us consider, what if I provided a orange, but I don't get any output. Okay, so here is a machine. Let us consider, what, here's a machine that I put my oranges into, and I get what, no output. So is it possible? It definitely shows that my machine is what, defaulty. My machine is defaulty. So next thing, what you said, what you learn from a definition, first thing is what, if I'm going to provide an input, then I'm going to get a what, a specific output for that. And next thing, what, if I'm going to provide a input, then definitely what, I'm going to get an output. Okay, if I don't get any output, that it means what, I had a defaulty machine. So the point from my definition. And let's take into another account. Suppose you have what, two aims. Okay, suppose you have what, two aims. This definition is from only for a understanding point of view, and it's mind made up definition. Okay, and here you are, okay, carrying a what, bow, carrying a bow in your hand. Okay, you have what? One arrow. One arrow. So you have two targets to hit with, and you have only what? One arrow. So you can either hit what? This, or you can either hit what? This, but you can't hit both. Okay, because you have only one arrow. So it means what? For one input, you can have only one specific output. Okay, I think I made my point here clear. So now consider what you have in your bow: one arrow and one arrow again. Okay, you have two arrows in your bow, and you have what? Two targets here. Okay, so what you can do? You can hit one arrow with that target and second arrow with that target. Okay, let us consider you have only what? One target, and you have what? Two arrows. So you can do that. Okay, but you can't do this process. You can either hit this, you can either hit that. You can not hit both the targets simultaneously. You can hit either this or that. But in the figure down below, in the figure second, you can what do? You can hit the target with both arrows. Okay, it is possible, but not the above situation. Remember that what? For each input we are going to get an output, and for each specific input we are going to get a what? Specific output. Okay, but we are going to get an output. And for what? You can have two arrows. You can have two arrows. You can hit the target, but you can't hit two targets with what? One arrow. Okay, because what? You have only one arrow here. Function as a special kind of relation. Function as a special kind of relation. So let A and B be two sets, be two non-empty sets. Okay, be two non-empty sets means they have some elements in their curly braces. A relation f from A to B, that is a subset of A cross B, is called a function, or a mapping from A to B if what? Let me complete the definition, then I'm gonna tell you what does that mean. Okay, for each A belongs to A, there exists B belongs to B, such that ordered pair A comma B belongs to F. And second, if ordered pair A comma B belongs to F and ordered pair A comma C belongs to F, then B is equals to C. Okay, so here I want to make sure that we have A1, A2, A3, dot 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 what? AN. And here I have what? B1, B2, dot 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 BN. So it is a set A and it is a set B. Okay. So here is a relation such that if we have what? A belongs to A, A1 belongs to A, we have what? B1 belongs to B. Okay. And they are what? Belongs to the function. Am I clear my point? So what I am trying to say here, for each element that belongs to the set A, we have an unique element belonging to set what? B. Suppose let me take an element A n minus 1. Okay, then what? I must have a map. I must have a blue map which must map it to what? B n minus 1 element. If I don't have this map A n minus 1, I don't have this map means that is empty, then it is not what function. The map must also there. Okay? The map must also exist there. And what does that means? Okay, let us consider another thing. Suppose we have what? An element A1 that is being mapped to element B1. Okay. And let us consider there is a what? A1 map which is what? Mapped to another element what? B2. Okay. It is not possible. Why? I had already told you in above example that you have what? Only one arrow. Okay. You have blue as an only one arrow, so you can use it to hit only either of the target, either one or two. So here you are doing what? You are using what? Yeah, blue arrow to hit both the targets. You can't do that. Okay. Your first element is same. You can't hit both the target. You can only hit B1 or B2. So here it means the same thing. So if you have the order pair A1 comma B1, and if your first element of order pair A1 with B1, and if you are mapping same element A1 with B2, it is not possible. As I had already told you, you have one arrow. Okay, you have one arrow A1, B1, B2. You can either map this one arrow with what? B1 or with B2. Okay, you can't map it both the elements. So I think I made my point here clear. Okay, what it's mean for each A belongs to the set A, it means that there must be a mapping for all the elements that belong to set A, and that mapping must be what? Unique. Must be unique. Mapping must be there. Mapping must be there. Just like I told you that the machine has to perform what? Operation, and that operation what is what? Unique. You are going to get the orange juice, not the banana juice. So you can try to relate my definition to the bookish definition here also. So I think I made my concept here clear of the bookish definition, and we have what? Function as a correspondence. So let us see what does that mean. Function as a correspondence. Okay, so let us consider, let A and B be two non-empty sets. Okay, then a function f from set A to set B is a rule or correspondence which associates elements of set A to elements of set B such that, okay, first all elements of set A are associated to elements of set B, and second, this association must be what? Unique. An element of set A is associated to a unique element of set B. So okay, so here what is nothing but the correspondence method. In this you had what? Let us consider what? Same set A, same set B. Okay, same set A, same set B. You have what? Elements in the set A1, A2, dot dot dot, AN. Elements in the set B, B1, B2, dot 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 dot, BN. So here it means what? A1 must be associated to some elements of B, and A2 must be associated to, and then we have what? All the elements of A must be associated to elements of B. and this association must be unique. What does that mean? That A1 must associate it to what? B1. It doesn't mean that A1 you can associate with B2. As I already told you, there is one arrow, you can only do the hitting target with only that one. Okay, so I think I made my point here clear. So it is the book's definition that I made easy for you using my definition. Okay, so you can either write this definition, you can either write this definition, or you can either write this definition with the what diagram. No one is gonna deduct your marks. You are get full marks. You are gonna get full marks if you're gonna write either of this definition. Okay. So I think I made my point here clear. So let's move forward and how you're gonna describe a function. Okay. Another topic is description of a function. So before doing that, let me take an example to you. And in this case, let us define what are the function and what are not. Okay. So you can clearly see that I have written function defining from a set A to set B, F1, F2, F3, and what? F4. So is F1 is a function? Is F1 is a function? No, F1 is not a function because you have what? 3 belongs to A, but for 3 belongs to A, you don't have any what? Any B belongs to B. It means you don't have any map for what? 3 belongs to A. You don't have this. Okay. So what? It is not a function. Okay. So F1 is not a function. F1 is not a function because 3 belongs to A and we don't have any B belongs to B. No, not a function. Is F2 is a function? Let us see. 1 belongs to A. For 1 belongs to A, we have what? This mapping. Okay, this mapping is unique. Okay. For 2 belongs to A, we have what? This mapping. This mapping is also unique. For 3 belongs to A, we have what? Okay, this mapping is also. And for 4 belongs to A, we have what? 2 mapping. C and D. I had already told you that you have what? 1 arrow only. Okay. And here you are clearly 4 is going to be associated with C and 4 is going to be associated with E. This is not possible. Okay. So F2 is again is not a function. Okay. So F2 not a function as 4 belongs to A. So F2 is again not a function. Why? Because you can clearly see that 4 belongs to A is associated with 2 elements. Okay. And I told you that this must be unique. Okay. So F1, F2 both are not a function. So let us move forward with F3. Is F3 is a function? Is F3 is a function? Let us see. 1, okay, belongs to A. This mapping unique. 2 belongs to B. Okay. 3 belongs to, and you can clearly see what? 2 belongs to A, you are going to associate with B. And 3 belongs to A, you are going to associate with what? B. So is it a function? Yes, it is a function. Why? Because I had told you that here you have what? You can hit the target if you have what? 2 arrows. I had told you. So here you are going to do what? You have 2 arrows. Okay. First arrow with 2 and second arrow with 3. You can hit the same target. Okay. But you can't do the reverse one. Okay. Just for example, in the function 2. And 4 is going to be associated with D. Yeah, it is a function. Okay. So F3 is a function. Yeah, I'm going to take that. So F4 is a function. Let us see. 1 for 1 belongs to it. There is an image. Okay. B. 2 belongs to it. There is an image. 3 belongs to it. Okay. And these images are what? Unique. Yeah. F4 is also what? A function. So I think I made my point here clear. What? You can hit the target with 2 arrows, but you can't hit 2 targets with a single arrow. Okay, you can't do that, but you can do this. Okay, you are going to associate 2, 3 with D, but you are not going to associate 4 with C and E. That's why F2 is not a function, and what? F3 is a function. So I think I made my point here clear. I can now say that I made your definition of function clearer more, and now I am moving in another concept, that is what? Description of a function. Let's move forward with that. Description of a function. Description of a function. So how you're going to write a function? Okay, So first and foremost thing you are gonna write a function is what? Suppose you have what a function f a to be defined as, you can write this, okay, or you can f1 is equals to some value it is going to attain. Like for example, if you have the set a, set b, and there is an element a1, a2, then a3. These are associated with unique elements to set b. Okay, so you can write f a1 is equals to what? b1. F a2 is equals to what? b2. And f a3 is equals to what? b3. Okay, so these are what the ways of writing an function. And here you can say that a1, a2, a3 are nothing but your domain of function. Okay, domain of function. And b1, b2, b3 are what? Range of the function. Range of function. So let us consider if there is an element extra b4. You can here clearly see that b4 what? Belongs to b, but it is not associated with any of the elements of a. Okay, it is a lone image. So if I'm gonna ask what is the codomain of b, codomain of function, then it is what? Whole set b. Okay, whole set b. But range has only b1 comma b2 comma b3, but codomain is going to be what? Whole set, that is b1 comma b2 comma b3 comma b4. Okay, so I think I made my point here clear. What is that? So you can clearly see that range of f is a subset of what? Codomain b. Okay, codomain b. So you can write the function by listing all the elements of first set, and here is the image of b, and it is called what? Image. The range is also called, the range of f is also called your what? Image of f. Okay, so one way of doing this is to write all the elements of set a and then to list all the elements of set b. A cumbersome work if you have what? Infinite list of elements. If you have infinite list of elements, suppose you have here what? Finite list of elements, you have what? 3 elements in it. So, and let's suppose you have infinite elements. Okay, then you are what gonna do? You are gonna write a function z to z. So sir, what does that mean? It means nothing but a function f which maps from set z to set z. Okay, what does that mean? It means that a function, the function from set z to set z. Okay, I don't know what are the elements in that, but you are going to do that. Elements must belong to what? Integer type of sets. Okay, so I think I made my point here clear. So you are going to see somewhere fi to r. So it means nothing, but it means what? That the elements of first set belong to r, and the elements of second set, the elements of second set belong to r. Okay, belong to r, because they are what? Infinite. So you have what? Second method of listing the function like that. So I think I made my point here clear. What is the domain, range, and codomain of the function? So let us move to another topic. What? Equal functions. Equal function. So let us consider a function f and g be two functions. They are said to be equal. First, if their domain are equal, domain are equal. Second, their codomain are equal. Their codomain are equal. And third, what? Their common f images are equal. Their common f images are equal for elements common in their domain. Sir, what does that mean? Can you please explain with that example? Okay, so let us define a function. Let us define a set A with the elements 1 comma 2, and let us define a set B with element what, 3 comma 6. Okay, so let us consider a function which maps set A to set B. Okay, function is nothing but a special type of relation which maps a set elements of first set to elements of second set. Okay, given by, you are going to list the formula that how is gonna define the relation. Okay, so it is the relation. Relation is nothing but a special type of what, Cartesian product of two set. Okay, relation is what, x square plus 2. Okay, and you have g here, another function defining as a to b, and now we are going to write the relation of g as gx is equals to 3x. Okay, so it means what, if you have set a and set b, and here are the two, 1 comma 2, and if you're gonna put the value in this f1, you are gonna get what, f1 is equals to 1 square plus 2, it means what, 3. So the first element 1 is going to be associated with 3. Now the second element 2, 2 square plus 2 is equals to what, 6, is going to be associated with what, 6. So we are going to interpret the set, or you can say it is how we are going to interpret the definition of a function associating two sets. And now taking, so here we have fx is equals to x square plus 2. Now we are going to associating another function g, set a to set b, 1 comma 2 taking the same element, 3 comma 6. Here I am going to define gx is equals to 3x. So if I am going to write g1, here I am going to have 2, g1 I am going to get what, 3 into 1 is equals to 3. So 1 going to map with 3, and second g2 is going to map with what, 3 into 2 is equals to 6. So this is how function map elements from set A to set B. Okay, so is the function fx and gx are equal? Let us see. First, are their domains equal? Are their domains equal? Let us see. Yeah, what is the domain of f, set A, set B? Okay, the first function f is having the domain A, and the second function g is having the domain A. Both are equal. Yeah, first condition fulfilled. Domain equal. Okay, now let us check another condition. Are their codomain equal? Codomain is nothing but the set B itself. Yeah, second condition too fulfilled itself. And what the final most condition is what, that their common f images are equal for elements common in their domain. So what are the elements that are common in their domain? 1 comma 2. Okay, so we are getting what, their f images, f1 we are getting 3, f2 we are getting 6, and here g1 we are getting 3, and here, so yeah, we can clearly see what, f1 is equals to g1 and f2 is equals to g2. Yeah, their common f images for their common elements are what, same. So yeah, you can clearly say that both functions are equal. I think I made my point here clear, how to define a function and how you are going to represent them using sets, and how you are going to prove that they are equal or not, or how you are going to define the domain, range, and what, codomain of a function. Okay.